So it's always going to be successes over total. But what did we do? Every time we had a card problem, we used what letter? C. They were all C problems, right? So quick review, just to make sure everybody's still remembering that from yesterday. If we had a 5-card hand and we wanted exactly 2 queens, do you remember how we did this probability? What did that look like? Tim? How many queens in the deck? 4. So it'd be 4C2. There are my queens. There are 4 queens, and I am going to pick 2 of them. Right? Okay, but now wait a minute. How many cards am I supposed to have? 5. How many do I have so far? 2. What are the other 3 going to be? Be careful. The other 3 are going to be anything except queens. So how many cards in the deck are not queens? 48. So that would be 48C3 divided by 52C5. Okay, so remember, these card problems we're using C's. We wanted exactly 2 queens. That means 3 cards that aren't queens. So if I have to write that down, I will. I mean, I won't in a problem, but if you need to write it down, you will. Okay? So I have 4C2, 4 queens. I'm going to pick 2. And then there are 48 other cards. And I'm going to pick 3 of them. And then why is it divided by 52C5? Because there's 52 cards and I am picking 5 of them. Right? So we did that yesterday. What other kind of problem did we do yesterday? We did the card problems and they were all set up just like this. What else did we do yesterday? The Venn diagrams. And the Venn diagram problems are the ones where you have, you know, a group of people doing one thing and another group of people doing another thing and some of them doing both. Remember M&Ms and Twix or jazz and country? So you have that overlap football area in the middle. Okay, well today we're going to do one more kind of probability. And it's on page 61. Number 7. If it rains tomorrow, the probability that Joe will do his homework is 40%. If it doesn't rain, the probability that doing homework is 10%. Given that the probability of rain tomorrow is 30%, find Joe's probability of doing homework. All right, now wait a minute. Wait a minute. What's going to happen tomorrow? It's either going to rain or it's not going to rain. So I'm going to do a tree diagram that shows rain and no rain. Now, what is the probability, according to the problem, what is the probability that it will rain tomorrow? 30%. So I'm going to put on this branch, on the rain branch, I'm going to put 30%. Now, if the rain branch is 30, what's the no rain branch? 70. Because what do probabilities always have to add up to? 100, right? If there's a 30% chance it'll happen, there's a 70% chance it won't happen. Okay, so here I am tomorrow, it's raining or it's not raining. Now, on both days, Joe is either going to do the homework or he's not going to do the homework. Would you agree? On both days, we're either doing homework or no homework. All right, so let's fill in these numbers. You got to read the question. It says, if it rains, that's right here. If it rains, the probability Joe will do his homework is 40%. So see this right here? I'm going to put a 40% on it because that's rain homework. Now what would this one be? 60. Because again, they got to add up to 100. All right, now what if it doesn't rain? If it doesn't rain, then what's the homework branch? 10%, which means the not homework branch would be 90. Now the question says, find the probability he'll do his homework. Well, he'll do his homework, kids, either on this branch. Would you agree he's doing homework on that branch? Or he'll do his homework on this branch. Would you agree with that? So there are two ways that he can do his homework. Either on a rainy day or a not rainy day. Now, to find the probability of this branch, it's rain and homework. So remember, what do I do when it's an and? I multiply. When it's an and, I multiply. So I'm going to take 30 times 40%, and that'll give me a 0.12. Now, what about this branch? I'm going to take a 0.7 times a 0.1, so that's going to be 0.07. And if that arithmetic bothers you, type it in on your calculator. To find the probability of this branch, I'm going to multiply these two together. To find the probability of this branch, I'm going to multiply these two together. Okay. Now what do I do with those two numbers? Remember, he's either going to do his homework on a rainy day, or he's going to do his homework on a not rainy day. What do I do when it's an or? That's when I add. So the answer to the question is 19%. There's a 19% chance he's going to do his homework. All right, let's look at 8. All right, if the cafeteria serves noodles, there's an 80% chance they'll serve salad. If they don't serve noodles, there's a 50% chance they'll serve salad. Given that they serve noodles just once each school week, find the probability that they will serve salad. Okay. So what probability do we know? We got two things going on. We got noodles and salad. What's the probability that we know? Well, but that's if we also have noodles. Read that first sentence. See, if we have noodles, there's an 80% chance we'll have salad. Given that they serve noodles once each school week. So they are going to have noodles or no noodles. What's the probability they're going to have noodles? Once every school week. So what would that be? 1 out of 5. So if I want to use decimals, what would 1 out of 5 be? 1 divided by 5. 20%. If you want to use 1/5, that's fine. What's the probability then they won't serve noodles? 80%. Now, what's going to happen either way? Either way, we might have salad or not, right? Either way. I want you to notice something. Go back to the homework problem. What was the question? The question was find the probability of doing homework. So homework was the bottom line. That was the end of the tree. Over here, what was the question? Find the probability of serving salad. So what's the bottom level of the tree? Salad. Whatever your question is, that's where your tree is going to end. That's going to be the second stage of your tree. First stage is the other thing, in this case noodles. Second stage is salad because that's what the question was. Okay? Now, how can we have salad? Well, we can have salad here. In other words, we can have noodles and salad. Or we can have no noodles and salad. Right? So here we go. Oh, I didn't fill in the rest of my probabilities. If I have noodles, what's my probability for having salad? Read the question. Doesn't it say 80%? So if that's 80, then this one would be 20. What if I don't have noodles? Then it's 50 and 50? All right, here we go. This branch, these are my salad branches. What do I do with the 0.2 and the 0.8? Because I am having noodles and salad. What do I do with these two numbers? Multiply. So that's going to be 0.16. Now I could have noodles and no salad. So I'll multiply those and get 0.40. Now I can have noodles and salad, or I can have no noodles and salad. So what am I going to do with those two numbers? Add them. So my answer is 0.56.
Would you put the answer and you change it to like 56%?
If you want to. It doesn't make me a single bit of difference. So 0.56 or 56%, either one. Alright, now our last question. Let's see if we can figure this out. We got lacrosse going on and soccer going on. It says, look at the question. The actual question you're answering is, find the probability of a student playing lacrosse. So when I start my tree diagram, am I going to start with lacrosse or with soccer? Soccer. Because I end my tree diagram with the question. And the question is lacrosse. So I'm either going to play soccer or I'm not going to play soccer. Now, what's the probability I'll play soccer? It should tell me in the problem. The probability I will play soccer is what? Read the question. 70. It says the probability of a student playing soccer is 70%. So this is 70%, and no soccer then would be 30%. Now, okay, I can also do lacrosse. So if I play soccer, I can do lacrosse. What's the symbol for lacrosse? Lax. Or I can do no lax. If I don't play soccer, I can do lax or no lax. All right, everybody good? All right, let's fill in these numbers. If I play soccer, what's the probability I will do lacrosse? 62. Which means no lacrosse would be 38. What if I don't play soccer? 48 and 52. Now I want to know the probability of playing lacrosse. So that's going to come here. That's lacrosse, right? Playing lacrosse. Or here. Alright. So what's the probability that I play soccer and lacrosse? What am I going to do with these two numbers? And what do I get when I do that? 0.434. I could also not play soccer and play lacrosse. What's that? 0.144. Now, how is she getting those numbers? Everybody know you're going to multiply these together, and you're going to multiply these together. Now, what are you going to do with these two answers that you get? Add them for a grand total of 0.578. That's 57.8%. Yes, indeed it is. Now, the notes are finished. I want to do a quick review here of our last, what our quiz might be. Back a few things I've got. And then I'm going to get everybody a quiz. That's, what are you okay, honey?
Yeah.
It's not doing very well. Here's last year's quiz. Now, we've been on probability for a few days, so we got to kind of think back to some other stuff that we've been doing. All right. So let's look. Let's look at question number 1. And see how far we can get. We're missing Savannah. Katie's out. Okay. All right, so here we go. Number 1. Boys and girls, tomorrow we have a quiz. Let's be ready for it. Problem number 1 says expand this. All right, does anybody remember anything about how to do this? All right, so at least Taylor remembers. She said, I don't know how to do the triangle, but at least she remembers there is a triangle associated with this. And the triangle is called Pascal's triangle, and it starts with a 1 and a 1.
Oh yeah, and then we do the 1, 2.
And every row starts with a 1, and then to find the middle numbers, you add these together, and then you end with a 1. So then I would start with a 1, add these together, end with a 1. Start with a 1, add these together, end with a 1. Now, how far do I need to go in this problem? I could keep going, but I only need to go to the 4th row. 1, 2, 3, 4. There it is. That's the 4th row. All right, so now I got the triangle built to the 4th row. All right, who remembers how we go from here?
You write it down.
We write down the numbers in the 4th row, and we give ourselves plenty of space. All right, so there are the numbers from the 4th row. All right, then what do?
Oh, you put an X in a 1.
I put whatever these are.
You put those all with them.
All across. So x and negative 2y go all the way across. What? It's not x and negative 2y in every problem. It's whatever is in your problem. So this time I have an x and a negative 2y. right? Now, anybody remember the next step? Well, they're going to be added together for sure. There need plus signs
You do like the
between them.
1.
But there's something missing. Lily?
X is so 1.
Yeah, I need exponents. I need exponents. And she's right. She says, okay, whatever your first letter is, it's X. It gets a 4. A 4. And then it goes down. And then what about the Y's? They go back up. Because every term has to have a total exponent of 4. And then you're done except for simplifying. So now we just simplify. So we remember that anything to the 0 power is 1. Anything to the 0 power is 1. So all we have here is x to the 4. Now what do we have here? Now remember, you're multiplying all that together. So you're going to have negative 8 x cubed y, because you're timesing the 4 and the negative 2.
So if it's to the 0 power, it just cancels.
It makes 1. Anything to the 0 power is 1. Yeah, so basically it cancels. Anything to the 0 power. Now, this is the tricky one. This is where you're going to make a mistake. What does this equal?
8. Oh shoot, 4.
That's 4y squared, isn't it? So when I do my multiplication, I get 24 x squared y squared. Why is it positive?
Because you multiply 2 negatives.
Exactly. Negative 2 squared is going to be a positive 4. All right, here, you're going to make mistakes here too if you're not careful. What's this?
Negative 8.
Negative 8y cubed. So when I multiply, I get negative 32 xy cubed. And then what about on the end?
16.
Positive 16 y to the 4th. The x's are gone because they're to the 0 power. Okay? Now, anybody have a question? These take up a lot of space. I may be confusing next up here. Anybody have a question about one of these things here? Now, the next one is actually the same kind of thing. Only it doesn't want the entire expansion. This is the entire expansion. First term, second term, third term, fourth term, fifth term, all the terms. The next one says, find the 5th term of this. So we don't need to do the whole row. Now we don't do all this work. We only have to find one of these. Okay? Now, you got to repeat all the steps though. So this is to the 7th power. So what do I need to do? I got to find my 7th row. So I'm going to have to erase part of this. So start with a 1, add, end with a 1. Start with a 1, add, end with a 1. Start with a 1, add. I'm out of room over there, but I may not need that anyway.
What's the short?
Combinations. This would be 7C7, 7C6, 7C5, 7C4, and so on all the way down. Now, if we were doing the whole expansion, we would have to write out that whole row. But we don't need the whole row. We need the 5th term. The problem says 5th term. So that would be the 1st, 2nd, 3rd, 4th, 5th. So the coefficient I need is 35. Remember when you copied the numbers down at the beginning? This time we're only copying one number down, the 5th one. What will be next to this though? Just like all of these. you'll have a 2x and a 3y. A 2x and a 3y. Because next to every term, you have these two things. Now, the only thing missing, I mean, I know I have to simplify, but the only thing missing at this point is what? The exponent. If you wrote out the whole row, your x's would start right here with x to the 7th, and this would be x to the 6th, 5th, 4th, 3rd. Now, there's nothing magic about that. What did I do? Count. So 7, 6, 5, 4, 3. So my x exponent is 3, which means my y exponent has to be what? 4. Because what's the rule? They got to add up to 7. All right, this is going to be a big number. The only thing left to do is what? Simplify. So we're going to have a 35. All right, now what's this one going to be? 8x cubed and 81y to the 4th. Now, these three numbers all have to get times by each other. So I need somebody to do 35 times 8 times 81. 22,680, and then you still have your x cubed and your y to the 4th.
Why was x cubed again?
What?
Why was x cubed?
Because here it would be x to the 7th, 6, 5, 4, 3. All right, next, number 3. How many ways can the committee of 2 Republicans and 3 Democrats be chosen from a group of 10 Republicans and 16 Democrats? All right, now wait a minute. This is kind of like a card problem, only instead of having, diamonds and hearts, you have Republicans and Democrats. So I have 10 Republicans and 16 Democrats. Okay? Now, I want to pick 2 out of this pile. So what's that going to look like? 2 out of this pile. Always the other way around. 10C2. So there we go. I've got my 2 Republicans. Here's my pile of Republicans. There's 10 of them. I picked 2. Now I need 3 Democrats. 16C3. I am picking Republicans and Democrats, so I'm going to multiply those together. Now, don't divide by anything, because it's not a probability question. It just says how many. All right, number 4. Same exact scenario, only now I have diamonds and clubs. Instead of Democrats and Republicans, I have diamonds and clubs. Okay? So what is the probability of getting 2 diamonds and 3 clubs? All right, so I want 2 diamonds. 13C2. There are my 2 diamonds. Now I want 3 clubs. 13C3. Now this is a probability question, so I have to divide 52C5. There we go, and that would be the setup for that one. Let's quickly go to the back page. We're going to run out of time. How many ways can the letters of We Love Math be arranged? All right, so how do we start? Yeah, we're counting up here, that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we start with 10 factorial. But what do we have to pay attention to? Are there any repeated letters? So I see 2 E's. So that would be 2 factorial. Anything else? That's it then. If I had, now listen, if I had 2 T's, I would divide by another 2 factorial. All right, calculate HC3 by hand. Who remembers how to do that? HC3 by hand.
You have to divide or minus the.
Well, we start with 8 factorial. We start with that number on top. And then we put this number on the bottom,
Oh, yeah.
but also on the bottom goes 5 factorial. That's the rule. You put this number on top, this number on the bottom, and then subtract those and put that on the bottom. There's 2 numbers on the bottom, always.
So when we take the quiz tomorrow, you want us to write out the numbers?
Well, you will not have a calculator tomorrow to do this. This has to be done by hand. So you're going to take 8, 7, 6, 5, 4, 3, 2, 1. We did this the other day. And we divide it by 3, 2, 1, and 5, 4, 3, 2, 1, and then a whole bunch of stuff cancels. And so the answer is 56. All you have left is 8 times 7 when you get done canceling. Yeah, you should. You did it wrong then. AC3 will be 56. Okay. Now we have 30 students in our class. 18 like English, 20 like math. All of the students like at least one of the subjects. So now stop and think. How many kids is this? Wait. How many kids is that? 38. There's only 30. So what does that mean? 8 were in the middle. If 18 liked English, but 8 of them have already been counted, that's a 10, right? And if 20 like math, but 12 or 8 of them have been counted, this must be a 12. So there are 12 kids that only like math. 10 kids that only like English. Yes, you go to 3rd period.
How do we know if it's both?
No, it's not out of order. Okay, this says all 4 of the students like at least one thing. Okay? Then you wouldn't know that. All right, have a good day. You're going to 3rd.